Hello, welcome to Tinkerdoodle DIY. In this video, I'm going to show you how to make a simple physics simulator using JavaScript code. As shown on the screen, we have 3 balls that move under gravity and they also collide with each other. Looks pretty nice, right? Okay, let me show you how to make it. First, let's have some very simple introduction to Processing.js. If you haven't known already, Processing.js is a very powerful JavaScript library that can be used to draw simple graphics. Like for example, we can easily draw a circle here using one function call. Let's run the code. Okay, here you are. We can see we draw a circle at this given coordinate, x equals 100 and y equals 100. But this object is static. So how can I make it move? It turns out you can use the draw function in Processing.js. So the draw function is called 60 times per second by default. And if every time we draw the circle at a slightly different place, then over time, it will make the illusion that the ball is actually moving. Let's see the effect. Okay, we can see the ball slowly moves from left to the right. So how can we make it move faster? Instead of increment the x coordinate by 1, we can increment at a larger step. So we define a new variable called velocity. And then let's make it 5 and let's see what's the effect. As we can see, the ball moves much faster now. We can not only move along the x-axis but also move along the y-axis. So for that, we define a x velocity, vx, and y velocity, we call vy. So we can say the ball moves along both axes. Now let's add gravity. So what is gravity? Gravity basically is the acceleration that changes the speed over time, the velocity over time. So by just adding this one single line that we change the velocity on the y-axis over time, it makes the ball looks like this. Cool, right? But it still falls out of screen. So how can I add boundaries to make the ball only bouncing within the bounding box? Yeah, so let's add some if statement to constrain the x and y coordinate to make sure whenever it hits an edge, then it bounces back. So we can see the ball only moves inside the box. Now you may wonder, how can we add multiple objects there? So to do that, we're going to use object-oriented programming to refactor the code a little bit. Instead of having the global variable x, y, vx, vy, we wrap them into an object. We call the object a body. And body has properties like x, vx, and y, vy, and a size. And the body class also has an update function, which updates its position as well as speed. So with that, it's easy to create a whole world with multiple objects. Like for example, we can put 3 moving objects here. We can see they're all bouncing by themselves, but they don't collide with each other. So how to add the collision? How do we make them collide? Well, before that, we have to use some real physics. So it turns out the collide is much harder than adding gravity. So let's say we have 2 balls that are moving towards each other and the kind of collide. Let's say this is the line along the center of the mass. And let's say we have ball 1. The velocity is like this. And then we have a second ball called B. And its velocity is along this line. Okay. So what will be the velocity after the collision? It turns out the velocity vector can be decomposed to have 2 components. One is perpendicular to the center of mass line, and another one is parallel to the center of mass line. We can do the same for the other object. Okay. So after collision, the velocity that is perpendicular to the center of mass line actually stays the same. But the velocity that is parallel to the center of mass line actually swap each other. So the velocity after collision will look like this. For the object A, its final velocity is those 2 vectors add together. And the final velocity for object B will look like this, which is those 2 vectors added together. Okay. So that's the physics part. Now let's convert that into code. So the code basically follows what we have described just now, that we decompose the vector and swap the components that are parallel to the center of mass line and compose the new vector for the after collision velocities. I'm not going to describe the code, but you can feel free to take a look in the shared notebook. Let's say the effect that when we're adding 3 objects and see if they're colliding with each other. Yes. So this looks much nicer now, right? Okay, so that's all for the how to write a physics simulator using JavaScript. Thanks for watching.